Hello everyone. Today we're going to talk about density. Density is a very important topic, not just in chemistry, you probably learned in CP and honors, but it's a topic that comes up repeatedly. I mean, not just basic density where an object floats or sinks, but we're in gas laws. You're going to learn about density of gases and correlate that to kinetic energy, speed, so it's an important concept that you need to understand. So let's first talk about like the basic principle of it, and then we'll do some calculations. So in density, you need to understand that density deals with another type of unit called a derived unit. And a derived unit is basically a combination of units. So the first example I can give you of like a derived unit is like volume. So probably in your math class when you took probably like the volume of a cube, and excuse my beautiful drawings. When you took a volume of a cube, well, you probably learned that volume is length times width times height. So let's say every single one of these, we were using maybe a ruler, we're measuring centimeters. So I have centimeters, and then centimeters, and then centimeters. Well, centimeters times centimeters times centimeters, well, that's centimeters cubed. And that's a derived unit. It's a combination of units, okay? So with that calculation, volume is an example of like a derived unit. Density is also, but I wanted to get to the volume part first. So the definition of a volume is the space occupied by any object. Now, the problem is with this, the state of matter really is important with this concept. So when we look at solids, we usually like to look at the units in what's called cubic centimeters, centimeters cubed, because it has to do with the solid. You can use meters, you can use other ones, but we usually use centimeters cubed. Liquids, we tend to use milliliters. So if you ever use like a beaker or graduate cylinder, they're always in mils because we're usually measuring liquids when we use a graduate cylinder or beakers. But gases, especially when you get to that big chapter later in the course called gas laws, you're going to notice that gases are measured in liters, okay? Because we're talking about huge amounts of an object versus like a liquid versus a solid. So we usually use liquid. And very important, liquids is the SI units that is communicated throughout the world. So when we talk about volume from one country to another, we use liters when we do that. A very important concept of converting units, okay? And I highlighted it because I want you to highlight it. It's very important. If we want to take mils, and remember mils is liquids, and if we want to convert that and change the state of matter, like what if we had some liquid water and we froze it to ice, solid water? Well, centimeters cubed is usually the one we would be using. So there is a correlation between it. That if you have 1 mil of water, well, that's the same thing as saying 1 cubic centimeter. And when you see how I use this throughout this video, and you'll see it in other videos when density comes back up, it's going to be like the light bulb that comes on. You're going to really understand why that's important, okay? Now, when it comes to gases, well, in a gas, it has a correlation too. But right now I'm talking about just liquids versus solid. So this is very important, this 1 mil to cubic centimeters, and you're going to want to have a box highlight, neon flashing lights going to it that we need to remember this conversion, okay? Before we calculate, we actually need to understand how to calculate density. So density is the ratio between mass and volume. Now, because states of matter change, the units will change. Well, notice mass is always grams, okay? So density is mass divided by volume. And usually when you abbreviate this, density, as you'll see in the next slide, we usually call density little d, okay? Mass is usually little m, but volume we usually make big V, okay? And you'll see that when you get to gas laws, we abbreviate volume as capital V. So if mass is always grams, no matter what state of matter you're looking at, it'll always be grams over something. But the problem is when you change the state of matter, the volume units will change. So with density is mass over solid units, which is centimeters cubed, or liquids is grams per milliliter, or gases is grams per liter, okay? So I bring this up because probably in your beginning chemistry course, honors, CP, whatever it is, you probably in the very beginning did like density labs where you took some objects and put them in water and you saw if they sank or float. Well, a very key thing to know about water is a very simple number. The density of liquid water, notice I said liquid water, is 1 gram per milliliters. And it's the standard. So usually if we want to see if something has a greater or less than density, we usually compare it to water. So if an example of this, I like to do this lab in my class where I take these different types of liquids and I put them in a cylinder or some type like a vase, and you'll notice that they sit on top of each other. Now, why do they not mix? Well, that's a topic later in chemistry called polar versus nonpolar. But why do they sit on top of each other in a certain order? Well, that has to do with density. So if, let's say right here we have water that sits right here, and water has a density of 1 gram per mil. Okay, remember I'm talking about liquid water. Okay, if anything is above water, we call that float. Okay, so if it floats above water, well then that tells me a lot about the density. Okay, that tells me that the density is less than water, so less than that 1 gram per mil. And if anything's below water, which means it sinks, then I know the density is greater than 1. So usually in a chemistry class, you will have to calculate what you think the density of that unknown liquid could be. Or if you're given a piece of metal, I like to use it's called the metals density lab, where we'll give them aluminum or copper or lead, and we ask you to calculate the density of it. And then we tell you what the real value is. And that has to do with percent error. So you'll see a video coming up about precision, accuracy, and percent error. So if it sinks, then that means that the density is greater than 1. Okay? So as you see right here, the density is basically the determination if something will float or sink. So if you do have an object that floats, that means it's less dense, and if it sinks, then it's more dense. But I always get this question about ice. So I put this picture in here. I got a glass of iced water. Well, if water as a liquid, its density is 1.0 grams per liter, and solid water, called ice, still water. But I'm sure everybody's house out there, they throw some ice in some water, and that ice is floating. But it's still water. But why does it float? It's because you have changed the whole structure of the water. You have brought those molecules closer together, okay? And because you did that, it changes the density because you have changed the volume, okay? So because of that, you'll notice that ice is floating. And because ice floats, then that tells me about the density. Does that tell me that the density is less or greater than 1? Well, if it's floating, that means that the density of ice is less than 1. And if you actually look it up, it's very close to 1, but it's not 1. It's like 0.98. Very close. But because it's not 1, it will float. But what about water in the vapor form? Okay, so like humidity outside, you got a lot of water in the air, and obviously right there, that would even be even less than 1 also, because gases, they float, not every gas, but water vapor does float, which means its density is even less than 1.0. Okay, we'll get into gases more, like I said, when we get to gas laws, but I just want you to understand about the sink versus float, okay? And just because it's water doesn't mean that everybody's density of water, whether it's solid, liquid, gas, they're all the same value. The state of matter will change the density, okay? So I put this in here because I like to help my students in the beginning with rearranging equations. And you can use this for any equation that has 3 variables. And what I mean by 3 variables is I have density. And like I said, I usually see density as little d. I got mass and I have volume. So I teach my students that if I have density is mass over volume, I do like a little triangle thing. And I put them in this actual order. It's got to be in this order specifically. So density right here, mass on top, volume in this side of the triangle. And I do like this horizontal and vertical line in between the 3 variables. So I like to think of this line up top, think of it like in basic math, like a divide line, okay? And I like to think of this line between the D and the V, I like to think of it like multiply, okay? So let me show you. If density, if I wanted to solve for density, if density is mass divide volume. So D equals M over V. What if I wanted to solve for mass? Okay, well, I want to solve for little m. What's left? The other two variables. So I have density next to volume, which means density times volume. I do this trick in the beginning because it's about the first math example we get to in chemistry, honors and CP. And we are basically trying to see your math skills for rearranging an equation, because you only get one equation of mass over volume. But whoever says you're always going to solve for density, you can solve for mass, you can solve for volume. So you need to be able to arrange that, because AP is not going to help you rearrange an equation. Okay, so there's the last one if you wanted to solve for volume, so big V. Okay, so big V, I have mass divided by density. So you could even do the little divide sign on this side. So mass over density. There are other equations coming in chemistry where it's a 3-variable one, and you can do this cool trick every single time. Like, for example, in chapter 4, you're going to get molarity. That's moles over liters. You can do it for this too. Okay. So one problem is that students have is they put the letters in the wrong spot. So just remember 3 very kind of magical letters out there in the world. That's so bad of a outline, but always remember DMV. DMV. Okay. So it'll always help you with that. Okay. So I did it right here also, but I wanted to show you how I worked it out. Okay. So when you show math, you always have to show AP basically your justification of your math. So I like to call it the know and the don't know chart. You basically have to sort out your information that you're given. So I make a little cross of a chart, and one side I put the know, and the know is what you're given. I mean, literally list every single thing that they give you. And what are you solving for? I like to call it the find, the question mark. Well, then you're solving for whatever they want you to find. So you can put the letter. Try to get used to writing symbols instead of words, because it's going to save on time. Okay. Once you figure out what you're going to solve for, then figure out how many steps to get there. Do I need to convert anything? Sig figs and order of operations. Okay. So I have several examples of density, and we'll go through each one. And if you want to stop the video and then I'll solve it, you can check your answer. Okay. So show all work with correct sig figs and units. What is the density of an object with a mass of 34 grams and 13 centimeters cubed? Well, when I'm looking at this, I'm thinking of several things happening. So the first thing I do is always do my know and my don't know chart. I know I have a mass of 34 grams, so little m, 34 grams, and I got a volume of 13 centimeters cubed. And I'm solving for density. Well, when I look at these type of units, I'm thinking I'm solving for a density of a solid because I got centimeters cubed. Again, it didn't ask us the state of matter, but it's something I got to keep in mind in case it's a question down the road that has maybe like a B, C, D, double E or something. Want to just keep thinking in the back of my mind of what am I solving for. So pure, simple, easy equation, plug and chug, and I put it up here on top just so that way you guys have it. You always need to write an equation, not plug the numbers in first. Write an equation. So density is mass over volume. I don't need to rearrange the equation because I'm solving for density. And mass is 34 grams and then 13 centimeters cubed. Okay? So all I'm doing is dividing. So I'm going to plug it in. Now question is, how many sig figs? Well, when you're dividing, it's the least sig figs between every number. So I got 2 sig figs on top, 2 on the bottom, so my answer, 2 sig figs. And the calculator tells me about 2.615, but because the number 6, the number after the 6 is a 1, I'm just going to cut it. I don't need a round. You have all units still viable because nothing canceled out. Now remember, when you divide or multiply, they don't have to be the same units, but if they do cancel, then they cancel. My grams and centimeters cubed did not cancel, so you need to write both of them. So 2.6 grams per centimeters cubed. When I do math, when I show it to my students, I always tell them to box their math answer so I know where to actually look. Okay. Question number 2, I'm going to solve for volume. Okay, so I'm going to read my statement automatically. I'm doing my chart. Okay, what is the volume? So I'm going to solve for volume, big V, of a liquid, and that has a density, so little d, 1.5 grams per mil. And I have a mass, little m, of 78 grams. Okay, so first is I need to rearrange my equation. Okay, so if it helps you in the beginning, do your little triangle, your little chart. Remember DMV. And I'm going to solve for volume. Okay, so what will be my equation? You never have to show AP how to rearrange the equation. You just got to show them an equation that you're using. So volume is mass over density. Okay, if you don't like the triangle type of trick, then just put density, mass over volume, but make sure you solve for volume. So you'd put like volume like X or something. Okay, so then my mass is 78 grams. And density 1.5 grams per mil. Okay. Now sig figs wise, I have 2 sig figs on top, 2 sig figs on the bottom, so my answer is 2 sig figs. Okay. But what about the units as I'm plugging it in? Okay. So conveniently enough, 78 divided by 1.5, not 15. You get 52. But units wise, I got grams. I want you to see this. I have grams over mils. Well, the grams will cancel. And then what's left? You have 1 over mil. So this is what's called, it's the inverse. It's the reciprocal. So 1 over mils. Well, what happens is when you take the reciprocal, the inverse, the mils come on top. So you are left with mils. Okay? Let's say it wasn't grams over mils. Maybe it's just grams over mils. Then nothing canceled out. Okay? So be very careful when you're doing units because it's not over 1 over milliliters. It was 1 over mils. So the inverse, the reciprocal, happened in here. So 52 milliliters. I'm going to solve for mass in this one. So I'm going to list my information that I know and I don't know. So what is the mass of an object? So I'm finding little m if my density, so it looks like I'm looking at a solid since the density is grams per centimeters cubed. So 5.7 grams per centimeters cubed. And my big V, my volume, is 48 mils. Okay, so I'm looking at mass and I'm thinking of my triangle. Okay, so DMV. And I always get students that say, well, doesn't it take time to draw that triangle and the lines and stuff? Well, I think it only took me 2 seconds. So I don't think it takes a lot of time to do that. I'm going to solve for mass, okay? And I'm going to solve for mass, which means my mass, I'm going to have density times that volume, okay? But I got a problem here. If I actually plug this in, let's see if you can figure out what the problem is. So my density is 5.7 grams per centimeters cubed. And I'm going to multiply that. Now you can put the times. I like to use parentheses. Volume, 48 mils. Now this has to be a red flag. Ding, ding, ding. Error, danger. Something's going on here. When you have density that has volumes of centimeters cubed and you have volume that has a different unit, you got to convert. Okay, and this is where this really cool trick of taking, because this milliliters, that's volume of a liquid. And this is grams per centimeters cubed. That means I'm talking about solid. I got to be talking about the same state of matter. And it didn't tell me what state of matter it wanted. It just said the mass of an object. So you either have to convert these mils into centimeters cubed or convert the centimeters cubed to mils. Most students would tackle this one, but how do you do that? Well, you simply say that 1 mil is a centimeters cubed. So what does that mean? Well, if 48 mils is what I have, well, then I have 48 centimeters cubed. And this is really important that you state this. I don't want to box it, but it's important that you state this so that way I can convert it. I don't need to explain to AP why I did it because I explained it right there. My point is you don't have to put it into words. You just have to justify what you did. So 5.7 grams per centimeters cubed. And now, instead of 48 mils, I have 48 cubic centimeters. Okay, so now let's look at the units. I know I'm going to have 2 sig figs in my answer, 5.7, 4.8, or 48, that both have 2 sig figs. But think of it as grams over centimeters cubed. If you don't see what happens to the units, maybe look at it over here. Grams centimeters cubed multiplied by centimeters is the same thing as saying centimeters cubed over 1. If you don't have a unit on the bottom, then it's just over 1. And right there, cross canceled right there. So I'm left with grams, and that should make sense, because what am I solving for? I'm solving for mass. I shouldn't have centimeters cubed left. So I plug this in, 5.7 times 48, 2 sig figs. The calculator, I'm just going to write it down, is 273.6. Oops, sorry, I'm writing on my little screen there. Grams, but I only need 2 sig figs. So remember, the original answer was 273. It needs to stay 200 something. So I get students that say, okay, I got to cut right there. So my answer is 27. No, it's not. It was 200 and something. Now you just cut it down to 27. It needs to stay 200 and something. So I'm still going to cut right there. But then what do I do with that 3? Just change it to a 0. So 270 grams. The last question before you go. Do you put the decimal there? If you put that decimal there, you make that 0 significant. And we don't want it to be significant because we only want 2 sig figs. Okay? Another key rule of when you're showing your work, ladies and gentlemen, you want to make sure you can show your work in one line as much as possible. If you run out of room, then just go to the next line. You don't want to show the work and then put your answer on a second line. You want to make it flow like a book. Go left to right and make sure at the very end you got that answer on that line. If you don't have any room, I understand. I write huge also. Then just go to the next line like I did right here. I ran out of room because my little video thing's right here. And I put the answer right here and I boxed it. So that way AP knows the box, that's my answer. Okay. Number 4, what if I want to find the volume of water? And I gave you a mass. Now you're probably looking at this and you're like, well, I got 3 variables, density, mass, volume, but I only know one thing. I only know the mass. I know my mass is 253.20 grams, and I'm trying to find big V. We're like, I'm missing something. I'm missing density. I'm missing density of water, and that's the ding, ding, ding. What do I know about water? You always got to know water's density, and water has the easiest number to remember, but remember, we're talking about liquid water, so the density of water, 1 gram per mil. Okay, so now I know, okay, I don't give my students a density of water because I expect you to know the density of water. If it would have been vapor or solid, well then I'd have to give you some assistance. But liquid water, we should all know what the density of water is, okay? So I'm solving for volume, so I do my little triangle, okay? So DMV, and I'm solving for volume, which means I have volume, mass over density. So my mass is on top, 253.23 grams, and I know my density is 1.0 grams per mil. And before I go on and plug this in, and honestly I don't even need to plug it in because it's the number divided by 1, but sig figs. When it comes to values that have a constant, okay, we don't do 1 sig fig. The true value for density is 1.0. I've seen textbooks say 1.00. You want to have at least the 2 sig figs with it. So if you put 1.0, 1.00, that's fine. But you got to keep with your sig figs. So if I did 2 sig figs for my density of water, then my answer is just going to have 2 sig figs. But it was 253 point something. But I only need 2 sig figs. So I'm going to put 250. Okay, because I'm going to cut right there, and the number after the 5 is a 3. What happens to units? I got grams over mils. The grams will cancel, and here's that same scenario again. I got the reciprocal happening with mils, so milliliters. Because I was given information about a chemical, you always put the chemical after the unit. So it always goes, I always chant this to my students, number, unit, chemical. If you know a chemical, you got to put it, okay? These other examples that just told us an object does something, we didn't know who the chemical was. Now, if you do 3 sig figs for that density instead, so instead if you showed it like this, 1.00 grams per mil, then okay, you have 3 sig figs instead. So then 253, and then grams of the water, okay? As long as you're consistent, you get the answer for either one. But if you only do 2 sig figs, then your answer would be 2 sig figs. Question 5, calculate the mass of a block of iron, and I told you the density of that iron, and the chemical symbol for iron is Fe, so if you want to put Fe instead of the word iron, and I told you the dimensions of that block, so I know one side is 52, I know another side is 6 point something, I know another side is 3.73. I want to calculate mass, but all you know is density. Well, you're probably thinking to yourself, I'm missing something. Well, what am I missing? I'm solving for mass, and I have density, 7.86 grams per centimeters cubed, and I have volume. Well, you don't have volume, but you got the dimensions to calculate volume. And when you take that length times width times height, then I can get my centimeters cubed, okay? So my volume, when I do this, okay, I'm going to tell AP what I'm doing. And that volume, I'm just going to list those 3 values, 5.28 centimeters cubed, or centimeters, 6.74, and 3.73. Okay? So first thing is, I can't solve for mass yet because I don't even know the volume. So I need to solve for that first. So I tell AP, length times width times height, okay? And then I plug the values in. I have 3 sig figs, I have 3 sig figs, and I have 3 sig figs. You can do this a couple ways. If you put the length and the width and the height next to these numbers like I did in the problem, then AP knows who your length and your width and your height is. There's no reason why you have to write the numbers again. But if you don't tell them who the length, the width, and the height is, then right after your equation, then you're going to have to put those numbers right after it, okay? Since I put it right here, there's no need that I need to do that, okay? So I'm going to plug this in, 52.8 times 6.74 times 3.73, and we only need 3 sig figs, so the calculator gives us 1,327, and I'm just going to write that down so you see, and then point something, something, something. I have 1,327, but I only need 3 sig figs, so I'm going to cut right there, but the number after the 2 is greater than 5, so I need to round that. So I'm going to go definitely a 1 and a 3. That 2 turns into a 3 and then 0. Do not put the decimal because then the 0 becomes significant. And then centimeters cubed. Now don't box this. It's not the answer. It's what we need to get to the answer. So I'm solving for mass, okay? And because I have done my triangle to death, that I know that density is multiplied by volume, okay? So mass, density times volume, I know that my density from back here, 7.86 grams over centimeters cubed. And I'm going to multiply that by that volume, 1330 centimeters cubed. And remember, if you don't have a unit on the bottom, it's the same thing as saying over 1. So these centimeters cubed will cross cancel, and then I multiply my answer. So 1330 times that 7.86, and I still need 3 sig figs. My calculator gives me a big number. Now, I would never spend time writing what the calculator says. I would just go straight the answer. But we're still practicing our sig figs. So 10,450, if I only need 3 sig figs, so it's right there, 1, 2, 3. 0 counts because it's a captive 0. It's between the 1 and the 4, so it is significant. The number after the 4 is a 5, okay? So you can round that 4 up to 5. So 10,500 and then 0, 0. So these are placeholders. They do matter because the answer was 10,000 something. You need to keep it 10,000 something. And then at the end I have grams and then I have iron, okay? And then I would box that as my answer, okay? So if by chance you're not given a volume, you can solve it by length times width times height. Or as the problem right before it, they didn't give you density, but you knew water, so then you knew water's density. My last question for this video is an important lab technique called water displacement. What if you had an object and you couldn't figure out the density of it just by going length times width times height? What if like the piece of object was like a metal, like platinum, as you see in the picture, and it's all rigid, it's not even close to being straight lines or like a cylinder or anything. So when you get to something like this, you take like a graduated cylinder of water, you put it to a certain amount, and then you drop the piece of platinum in, and obviously the water's going to rise. And how do you find the volume of the object? You subtract the two values. Water is not the key component to the story, just water's needed so we can figure out the volume of that piece of metal. So I took a picture and I gave you a scenario. Let's say you had a original volume of water. So I'm just going to write down some info because I don't think I can write on my picture, but we'll see. I have this 5, and it looks like it is being counted by, so this is 6 and 7, and I think I have my information in the video not correct. So it looks like 6, 7, 8, and 9, because this is the 10 line. So it looks like when you are doing volume, very key is you need to read the bottom of the meniscus. Okay, and the bottom of the meniscus, it's the bottom part of the curve. That is the true, accurate way to measure liquids. Okay, every liquid has that U up-shaped curve to it, and if you have a big container, you really don't see it. So it really helps if you have like a test tube, you could actually see the U-shaped curve to it. The only one that doesn't have a U-shaped curve to it is mercury. Mercury actually has an up-down, upside-down U-shaped curve to it. And you'll learn about that when you get to a topic called adhesive and cohesive forces. So right here, it looks like my meniscus is right there exactly on the line, the 7. So I'm going to say this initial volume, I'm going to call it V1, is 7.0 milliliters. And it's very key measuring equipment correctly with placeholder numbers, as in sig figs. I not only knew that was 7, but it was hitting the line, so I know it's exactly 7.0. If it would have been like between the lines, then maybe it would have been like 7.5. So you do have to give that extra significant figure. Remember that number, that last digit's called the estimated value. Maybe your eye sees 0, maybe your partner sees 1. It's okay, it's an estimated digit. But we should all have 7 point, at least 0 or 1. I threw my piece of metal in, and according to my piece of metal, look what happened to the water level. The water rose. The water level went up. Did I add more water to the story? Well, let's just double check. The level of water in a graduating cylinder is 5.7. Well, we actually know it's 7.0. When a piece of platinum crucible is placed in the cylinder, the water reads 20.5, and we'll double check that with the picture. It doesn't say anything about water being added. So the water went up, but the volume of water didn't change. And that's key to it, because that means that this change in volume from here to here, that means it's the volume of platinum. So first I got to read, what is my final volume? So I can call it V2, VF for final. And I notice right here that it is definitely above 20. But first, make sure you see what it's counting by. So this is between 20 to 25. So this looks like it's 21, 22, 23, so forth, so forth. Now, this meniscus right here is not on the line. So it looks like it's between these two lines. So 20.5 looks like an accurate V2. So first, I need to figure out what is the volume of this piece of platinum. Okay, so I just call it volume plat. Or you could put volume metal. Okay. So when you're doing the volume, it's the final minus the initial, or the V2 minus the V1, okay? So my final was 20.5 mils, and initially I had 7, oops, sorry, not equals, minus 7.0, okay? So 20.5 minus 7.0, subtracting sig figs, the least after the decimal. So when I subtract these, I only need 1 after the decimal, and it comes up to be the volume of this piece of platinum is 13.5. And that's milliliters. Now before I go on, I need to find the mass of platinum, but I can't find the mass until I think about this piece of metal. I'm looking at this volume, 13.5 mils, and I'm looking at that unit right there, and I'm like, wait a minute, volume in milliliters? That's for liquids. I don't got a liquid. The only liquid I have is the water, just so I can figure out what the piece of metal, platinum's volume is. I can't use mils when it's a piece of solid. I need that centimeters cube. So we're going to convert it, but a nice little trick. Just need to state it. 1 mil is 1 cubic centimeter, and now I can change these mils into cubic centimeters. So now my volume of my platinum, and actually I could have put it right here, 13.5 centimeters cubed. Okay? And this all right here, this is your showing. This is your justification to AP of what you're doing. Okay? You have to make it organized and concise so that way they know what you're doing. They don't have a lot of time to grade your responses. They get a certain set time and it needs to flow. Okay? So I know right here I was given the density of it and I found the volume right there. Okay? So I have my mass, and I know from rearranging my equation, mass is density times volume. And now I have my 13.5 centimeters cubed, and I have my 10.997 grams per centimeters cubed. Apologies, I'm down at the bottom of the PowerPoint. 3 sig figs times 5 sig figs, I need to have my answer with only 3 sig figs. So 13.5 times that 10.997, only 3 sig figs, I get 148. Okay, and sorry, I'm going to put my answer up here at the top. So my mass, I'm going to get 148. And look, notice what happens to the units. I got centimeters cubed times grams over centimeters cubed. Those centimeters cubed, oops, sorry. You always have to show how the units cancel. So the centimeters cubed cancel with centimeters cubed. It wants to get to the next one. They will cancel, and you're left with those grams. It does tell me who the object is. It does tell me platinum. If you don't know the symbol for platinum, it's PT. So if you don't know it, you just write the word platinum. Okay? I hope, ladies and gentlemen, this video was very helpful in finding density. I try to show you different scenarios with it. It's definitely a key concept. You not only have to understand conceptually, but also mathematically. Okay? So I'll see you on the next one, and it looks like the next one we're going to do some precision and accuracy.